Here is the second behavioral design pattern from the famous Gang of Four design patterns book. This one is called command pattern, and it is a pattern you use when you want to encapsulate an operation as an object. I'll start with a quick summary of what we are trying to accomplish with this pattern. The command pattern is a good choice when you are trying to accomplish the following. You have a client that knows what needs to be done, and you have a receiver that has the resources for doing it. You want to package operations into self-contained objects and pass them from client to receiver. Okay, let's go through these points one by one. The key intent of this pattern is that you have two distinct classes in your application architecture, a client and a receiver. And the client needs to invoke some kind of operation on the receiver object. The client does not call the receiver object directly, but instead it creates a command object. This is an object that defines the command to be executed and contains any required arguments. The client then hands the command over to an invoker object, which executes the command. The command is effectively a black box with a single execute method. When called, it in turn calls low-level receiver methods to perform the operation. Materializing commands into discrete objects means they can be transferred, shared, stored in a database, and otherwise instrumented or manipulated like any other object. The command pattern offers a number of benefits. The first benefit is that by materializing commands into objects, you gain the ability to store commands, and this allows you to queue operations or write them to a log file. And you can also store commands in an undo list, which allows you to implement undo and redo operations. Another benefit is that the invoker and receiver of a command are completely decoupled. You can change at runtime how a command is executed without the client noticing. Here is the UML diagram of the command pattern. The command class at the top of the diagram acts as the abstract base class for all commands. It defines a single method called execute, which will execute the command. There is a derived class called concrete command, which inherits from command and implements the execute method. The class contains a reference to a receiver object called, receiver, and it uses this reference in the execute method. You can see in the diagram that the concrete command class calls a method called action in the receiver object to execute the command. The client class instantiates the concrete command and initializes it with a receiver instance. It then hands the command over to the invoker object. This object finally executes the command by calling its execute method. In practice, you sometimes see the client and invoker merged into a single object, which will both instantiate the command and invoke its execution. I am going to implement the command pattern in a very simple calculator application. My application will perform 4 mathematical operations: addition, subtraction, division, and multiplication. I will use the command pattern to implement each possible operation as a command object. By materializing the operations into discrete objects, I gain the ability to store the operations in an undo list and implement an undo method. I will create a simple user interface to input calculations, which will act as the client. The receiver will be a mathematical library that implements the 4 operations and keeps a running result. So, I will implement the pattern with these classes. Okay, let's take a look at the code. I will start with the mathlib class, which acts as the receiver. It's a very simple class that declares 4 methods for the addition, subtraction, multiplication, and division operations. Each method expects a single integer argument, performs the requested calculation, and updates an internal field called value. Now let's move on to the abstract operation class. You can see here that it is a very simple abstract class that sets up a single abstract execute method. This will be the method that executes the mathematical operations. And here is the concrete command class, called operation. The class derives from abstract operation and implements the execute method. So let's take a look at this constructor here. You can see that the constructor expects 3 arguments: the receiver of type mathlib, the mathematical operation to perform, and the argument to use. The constructor stores all 3 arguments in internal fields. When we look at the execute method, you can see that the class uses a switch statement to call the corresponding method on the math library. Okay, next is the interactive shell class, which acts as the client class. You can see here that there is a single run method that launches the shell. The class reads a single line from the console, parses the input, and extracts the operation and the argument. It then instantiates a command object from this data and passes it on to the calculator class. And here is the calculator class, which acts as the invoker in this pattern. You can see here that there is a method called invoke, which receives the command and executes it by calling its execute method. But the calculator also stores the command in this undo stack here. And by storing the commands, we gain the ability to introduce an undo operation. And here it is. The method pops the most recent command from the stack. It then inverts the operation and executes the modified command. This will effectively undo that operation. Okay, let me run the program to prove that everything is working. I am compiling the code now. And I'm running the program now. Okay, so now the interactive shell is waiting for me to enter commands. I will start by adding 100, then subtracting 50, multiplying by 10, and dividing by 2. You can see the current value constantly updating from 0 to 100 to 50 to 500 and finally to 250. Now I will undo the last 3 operations. I will press tilde and the number 3, which the shell interprets as an undo of the last 3 operations. Here we go. And here is the result. The calculator has undone the final 3 operations, and the current value has been restored to 100. Everything works. Okay, here is a quick checklist you can use to implement the command pattern. First, create an abstract command base class with an execute method. Then create one or more concrete command classes that contain a receiver field plus a complete description of the operation to execute. Implement the execute method by using the receiver field to call methods in the receiver object. Instantiate a new command object for each deferred execution request. Hand the command object over from the client to the invoker. And finally, have the invoker decide when to execute the command. Okay, here are some final comments. You can combine the command pattern with the composite pattern. And this allows you to create macros. These are high-level commands that are composed of a sequence of low-level commands. The composite class represents the high-level command, and its child components are the low-level commands. The command pattern is part of a group of patterns that it shares with the chain of responsibility, mediator, and observer patterns. Each of these patterns allow you to decouple senders and receivers, but each pattern comes with different trade-offs. The chain of responsibility pattern can use command objects to represent requests as objects. This adds the benefits of queuing, logging, and deferred execution to the benefits of the chain of responsibility pattern. And you can combine the command pattern with the memento pattern to maintain the current state of an object and easily implement an undo operation. Okay, to wrap up, here is a summary of everything that we have learned in this lecture. The command pattern encapsulates operations as objects. Materializing commands into objects means they can be transferred, shared, stored, and otherwise instrumented or manipulated like any other object. And this lets you queue, log, undo, or redo commands and defer execution. The pattern can be combined with the chain of responsibility pattern to create chains of request handlers with queuing, logging, and undo capability. The pattern can also be combined with the composite pattern to create macros.